U-substitutions with definite integrals. So there's really nothing new here. You could do U-substitutions just the same, but I want to go through this process to point out where a very common mistake occurs. So again, we have a ratio, and so we'll try u equals 1 plus x cubed, the denominator. Well, then, of course, du equals 3x squared dx, which, quite fortunately, is the numerator. And so what we have here is an integral, and we just have a du over u. Now, the limits of integration, here's where I'm going to be careful. The integral is now written in terms of u, but those two boundary conditions, 0 and 2, are in terms of x. So I'm going to write x equals 0 and x equals 2. I'm going to make it very explicit that those two numbers are in terms of another variable. Then we do our integral. We evaluate, of course, log u, integrating at x equals 0 and x equals 2. Now here's where the mistake might occur. If I had not been so careful, if I had just been writing integral from 0 to 2 and then evaluate at 0 to 2, I might plug in 2 and 0 directly into u at this point. And then I'd run into some problems because I get log 2 minus log 0. And in fact, log 0 is undefined. So you might actually conclude that the integral were undefined. But of course, this is not the case at all. In order to plug in those x limits, what we have to do is convert everything back to in terms of x. Well, now that we have log of 1 plus x cubed, now we can just write 0 and 2. Now everything is in terms of x. Now we can plug in. We get log of 9 minus log of 1. And of course, this is just log 9. Another choice we would have, a completely different route through the problem, is when we got to this point of rewriting the integral, du over u, right there we could just rewrite the limits in terms of u. So when x equals 0, u equals 1. When x equals 2, u equals 9. And so we could just have a limit of du over u, integral from du over u, from 1 to 9. And now we don't even have to write the u equals because everything is in terms of u. So this would just be log of absolute value of u evaluated at 9 and 1. Log of 9 minus log of 1 gives log of 9. And so you're welcome either to change the limits of integration, writing them in terms of u, or keep them in terms of x, but then be very explicit about writing x equals for your limits of integration, because it's very easy to start plugging in values of one variable into another variable inadvertently if you're not keeping track of which values go with which variable.